I'm Robert Cohn. I'd like to introduce the speakers for this session. It's Matt Makai. He's a developer evangelist at Twilio, and Kate Heddleston, who's a software engineer and currently fund employed. And they'll be talking about choosing your own WSGI deployment adventure. It's going to be a little different from the other talks. I think it'll be very exciting. And I should take it away.
Good afternoon, everyone. My name is Matt Makai. I'm a developer evangelist with Twilio. So this is Choose Your Own WSGI Deployment Adventure. And as Robert alluded to, this is going to be slightly different from some of the other talks. We need audience participation here. And you are going to participate via either a phone or a laptop. So this is the exact opposite of what most speakers want. Pull out either your phone or your laptop, get it connected to Wi-Fi, because we're going to need you to help us figure out which paths we choose through this story today. There's going to be multiple decision points where we'll need you to do voting via SMS or the web browser, so one or the other, and we'll explain that when we get to our first decision point. So I would like to introduce my esteemed co-presenter for her second talk of the day today, Kate Heddleston.
Hello. My name is Kate Heddleston. I'm a software engineer. I am fund employed. I don't work at Twilio, so only one of us is affiliated with Twilio. Here's our story today. You have started the hottest new company in Silicon Valley. You are a group of dudes engineering things, and you have convinced some investors to fund your idea. Now you have to build it. Did you build Tinder for Pets, the hip new app that connects lonely pets at home for daytime meetups, or did you build the Dachshund Delivery service, which is a product that deploys an army of Dachshund to deliver documents and track analytics? So here's your first voting point. Did you build Tinder for Pets or the Dachshund Delivery service?
Here's how this works. So you send, if you have cell phone service, so I know not everyone else cell phone service here, but if you can send an SMS, you can send an SMS, this is a Montreal number, to, and we're already getting in votes, send an SMS to that number on the screen, or you can go to j.mp/PyCon-app, and then you will have the option, there'll be two buttons on the screen, so you can vote for which app that we're going to choose here. So this is going to be, we'll have multiple screens that are like this, so the URL will change as we go along, but this is how we're going to be able to vote through our app. So it looks like head-to-head.
Oh, wow, Tinder's pulling. This is exciting. This is riveting. I think we might.
So the WebSocket voting is based on your browser, so you have to stay on the page for the actual vote to count. So stay on the page if you're using the web browser voting, and that will allow it to continue to count your vote here. So what's happening is we're calculating in a Flask application the votes that are coming in. We're incrementing Redis or decrementing Redis if you leave the page, and we're counting the number of votes that are coming in.
All right. We might have some duplicate votes. I don't know if we have 110 people here, but it looks like the Dachshund Delivery service is going to be the winner. So you built the Dachshund Delivery service. And this is actually a joke product launch that my brother's company did, so we have a video for you.
Here at Dachshund HQ, we have nailed document delivery in the digital world. The question has been, how do we translate this experience into the physical world? Today, we're excited to reveal the Dachshund Delivery service.
When you need a document delivered, go to dachshund.com and place your delivery request. A Dachshund will shortly arrive at your front door. Simply strap the document to the Dachshund's carrier, and your document will be on its way.
Once your recipient receives the document, our highly trained Dachshund will pay close attention as it's read. The data will be carefully tabulated and reported back to you. Dachshund Delivery comes with a special added feature, shred after reading, freeing you from any worries that your document gets into the wrong hands.
Ready to give our latest creation a spin? Just head to dachshund.dachshund.com and start sending today.
All right, So you're working on building the hottest new app since Color. This is going to be amazing. You've got the code ready to go. It's all built on your local development environment, but now it's time for you to deploy. So what does that look like?
So we have our application code. We've built our Dachshund Delivery service. I will trip up on that multiple times. Now we need to do something with it. So what do we do with our code that's running on our local development environment so that other people can actually start using it? So let's take a look at a WSGI deployment. What we need is a map of what our deployment should look like. A map kind of like this, only with our WSGI deployment instead of just like the old style here. So caveat, I am not a cartographer. So I was trying to draw a map that would look really nice just like this. And unfortunately, I came up with balsamic mockups. And so that's what we're going to be drawing as far as our map today. So we'll clear away the continents, and we will start with the internet. So on the internet are users that want to use our Dachshund Delivery service. And we have our application code sitting on our local machines. That doesn't do us any good. The users can't use the application. What we need is a server. And the server, we can go out and buy hardware, stick it, connect it to the internet, or we can go and have go get a virtual private server from a company. So for example, we could go out and we could go to Linode and get a server. The reason why I picked Linode is because that's actually what's running this application right now. So if we have any problems with this, we can all just go downstairs and yell at them at their booth. So we take our Linode, we spin up a server, we provision a server, we spin it up, we SSH in. We're in our new server as the root account. Now we want to get our application code onto our server. So we're using GitHub to save our code. We would go and git clone our Git repository, so we would get our app code, and we'd put it on our server. Next, we need a web server, so we'd go sudo apt-get install nginx, and we would configure our nginx server. So here's the thing, though. Our team's not that experienced with this whole operations deployment. So we go on Stack Overflow, we copy and paste some code, and we just try to make our configuration work. So the first few lines, we're not really sure what they do yet. They say something about a WSGI thing, but we'll worry about that later. We're just trying to get nginx up and running. We have our server listening on port 80 so it can start responding to requests. And we configure some basic logging. And then at the end, we copy and paste what we've seen on Stack Overflow for this WSGI server thing that we need to figure out in a few minutes. All right, we do a restart of our nginx server so that we can get the configuration taken up. And now, when people go to our website, they see a 502 bad gateway. All right, what's happening here? So when people are going to the website, when they're going to our application, the web server is acting as a proxy. So the proxy is just the middleman. It's saying, OK, I'm getting an incoming request, and I need to hand this off to a port 5000 upstream, some sort of upstream server. So clearly, we need to set this thing up. What we need here is a WSGI server. So we have our web server that's handling the responses. We're handling requests from users. And then we need to go and hit a WSGI server that is going to be running our application code. So we would go and do a sudo apt-get install python pip. We would install our dependencies, and one of our dependencies would be Green Unicorn. That's going to be the WSGI server that can run our application. But we're not really sure exactly how to run Green Unicorn. We keep using run server on our local development environment, so we'll just use that for here. Now I know at this point many of you who've done deployments before are shaking your head. You're like, whoa, you're configuring a production server with like run server, the dev server? That's like a really terrible idea. But this is our first deployment. We're just trying to get our MVP up. If you have a problem with that and you see someone else in the audience who's like, oh yeah, taking notes, like, okay, I do run server, you can help them out and show them how we should actually do this in a safe, secure way. But for now, this is what's going to be running our application. Okay, now people go and they would see something like this. They'd see plain HTML. And what should happen is, for example, when you go to a web page, what should happen is we should see, okay, we get not only the HTML, but we get images and JavaScript and all that stuff. This is what happens, the request response cycle. But we haven't configured our web server to handle the images and JavaScript and CSS that should be bringing up our application. So we need to set up static file serving. So we go and change the configuration of Nginx. So below where we had our log configuration set up, we would put in 4 lines at the location /static. So any URL that has static in it, we are going to have an alias to our var www app static directory. This will allow Nginx to serve up the static files itself. And then we have the rest of our configuration, which we had already put in. And so now we have our complete deployment, complete initial deployment, well, except for one other step. So our angel investors told us that there's something called, the data that we have is really important. So data is like the new oil, is what the angel investors keep saying. So we need some sort of database to store information about our Dachshund Delivery service. So we do a Postgres installation. We install a client so we can access Postgres. We do a create DB for our application, Python manage.py sync DB, so we create our database tables for our application, and then we load some initial data. OK, now we're set. We've got our web server. It's serving up images of pets that could be doing delivering. And we've launched. Finally, the world can use our Dachshund Delivery service. Even better, we're featured on TechCrunch. We have hypergrowth, not just growth. We have hypergrowth now. So with hypergrowth comes more problems. So the question is, do we have so many users that are signing up for our Dachshund Delivery service that we need to make email invites? Or do we need to set up automation because we keep having to manually log into the server and do SSH, update our code? So the question is, are we doing email invitations, or are we going to automate our deployments? So the question, or the path to the story, is up to you. So this is the same number that we had before, and then this is a new URL. So we have a j.mp/pyrocket. We'll see what people think.
This is a close race. I think it's a little unclear to me which one you guys prefer. For anyone thinking, by the way, that this couldn't possibly be how companies launch, it is. Snapchat.
All right, we're going to cut at this point. So automation is clearly key to being able to quickly iterate on our MVP. So we're going to walk through automated deploys. This is just going to be a very high-level overview of automation. Now, I thought this picture was just, I don't know, it just cracked me up. So what I decided was this was going to be the TV section of the Choose Your Own Adventure story. So I tried to put in as many TV clips as possible throughout it. OK, so we want to automate. Instead of having a human do everything, we have a, well, not a robot, but we have software doing it for us. So we start looking for what configuration management tools are out there. What would allow us to automate? And we see these things, Fabric, SaltStack, Docker, Ansible, all of these tools and DevOps, and like, what is all of this stuff? So we call up, we call up a friend. We're kind of lost. We phone a friend. And they say, all right, what do you want to automate? Right? So that's the first thing is, let's just start answering simple questions. Like, what is it that you want to automate? We've got to start somewhere. We say, all right, well, I just don't want to SSH into the machine every single time. And so what we need to do is we need to pick some tools that will handle deployments for us. So we can start bucketing these tools. If we know nothing about the configuration management tools and the deployment automation that's out there, we can bucket them. So for example, in this case, we would have under server state, Chef, Puppet, SaltStack, CF Engine. This is great for managing the state of a server. What packages should we have installed in there? On the other side, we have something that's akin to deployments. And so we have shell scripts, Capistrano, Ansible, and Fabric. So we decide, OK, let's pick Ansible and Fabric. We write some scripts that allow us to, instead of us having to manually SSH in and pull down the code, we automate those with some Ansible playbooks and some Fabric functions. And then we add continuous integration. So let's go back to our map here. What we have is the application that we had set up. And now instead of us having to SSH into the machine and pull down our app code from the source control, we get it through continuous integration. So we work on our code locally. We push it to the source control repository. The continuous integration environment is notified. And then it builds the code. It maybe tests at some point in the future when we actually get time to write some tests. And then we deploy the code through the continuous integration. So we no longer have to SSH into the machine to do every single deployment. So finally, we have some automation in place. Now, this creates some other issues. You've configured and deployed your environment. But now, do we have HTTP requests that keep timing out because we're trying to get too much work done? Or do we have too many bugs that users are reporting and we're not sure how to handle them all? The choice is up to you. So again, same phone number. It's j.mp/async-fix. Neck and neck.
I don't know, I think we should call it. Okay, so you chose to build an asynchronous service. This is a pretty common thing that comes up very quickly when you're building a web application, right? So this is a picture of minions, because that's how I think of asynchronous services, as automated minions going out and doing your bidding behind the scenes. But basically what happens is someone's using your application, and when they come in, they might click a button, and your application might go crawl web data. But making network calls out to the rest of the web and getting a bunch of new data is actually fairly slow. And you don't really want to block user interactions on making calls out to the rest of the web to get data. So you need an asynchronous task service to go out and do these things behind the scenes while users can still go around your site and do a bunch of different things. So this is a nice little diagram. Basically what happens is a client comes in and they initiate a call. And rather than blocking and saying, okay, we're going to actually go out, crawl all this web data, get information that you want, and then 4 minutes later, the button is going to stop loading, and it's going to be like, you're done, because your user was gone like after 5 seconds. They're not going to wait 4 minutes for your application to go and do all of these tasks behind the scenes. So what you do instead is you just send a callback that says, all right, we've received this task, and we're doing it behind the scenes. Like, we'll let you know when we have the data that you need, and we'll send you a notification, or we'll send you an email, or whatever it is. The asynchronous web service then behind the scenes has queues of these different tasks. And these queues run, and they process the tasks. Usually, asynchronous tasks involve things like going out and getting data and updating the database, or sending emails, or doing kind of network-intensive calls that you really just don't want to have happen in real time. Or sometimes you have a web crawler in the background where every day you go and update information. So maybe every day you want to go and update Facebook likes for some reason so that you can track engagement. Or every day you want to go out and crawl certain things to get news about what's happening in the world. And so those are time-intensive tasks. And it gets through these queues whenever it gets through these queues. A lot of times when you are using a third-party service and you send an email, or you kick off a task and it takes an hour, that's because the queues get really backed up in some asynchronous service. So it just ends up going to this black box, and then an hour later, finally, your task gets processed. But it's okay, because when it's done, it will send a response, and you can notify users that the data is there, or they'll get an email or whatever it is that the task was doing. So a lot of people talk about Celery and RabbitMQ. That's a very common tool to use in the Python community. There's actually more lightweight tools. So if you're getting started with asynchronous tasks for the very first time, and you're like, Celery and RabbitMQ are a lot of overhead. It's a lot of documentation to read. There's an option that's a lot easier that I really like for getting up and running with a new web application. And you can use Redis and Python RQ. So Redis is just a key value data store. You can install it locally. You can install it on your production servers. You start the Redis server on port 6379. I don't know, whatever is the port that you normally start it on. And Python RQ is just a Python library. So you can pip install Python RQ, and you start the Python RQ task listener. And in your code, you go through, and all you do is it's one line where you enqueue function calls. So let's say you have a function that's crawl Facebook data. This function is what goes out, does the network calls to Facebook, gets back information about someone's profile, things like that. So when a user comes in and signs up or does this task, the function goes through, and rather than actually making the call out to Facebook, it enqueues this function call. And it's like, all right, stick this in our Python RQ and do this later. And then continue with the rest of this function, return to the user, and let them get back to their daily lives. And then in the background, Python RQ is listening, and it's like, yay, a task, okay. And it goes out, and it goes to Facebook, and it runs this function, and it gets all of the data, and it updates things, and it does exactly what you tell it to do in this function, because you've written the code that's being executed. So when it's all done, you can either send a notification, or sometimes you just do nothing. Sometimes the data just appears in the application, and that's good enough. But it's happening asynchronously. So the user isn't blocked, and this code is running in the background. And Python RQ also has a scheduler, so if you want to schedule tasks to be run at a certain time, which is another common asynchronous use case, you can actually use our RQ scheduler with Python RQ, and they're both Python libraries that you just pip install, use on top of Redis, and it's fantastic. So you can schedule it to crawl web data, you can schedule it to do tasks in the UI, and I love these for getting started. When you start to have really big asynchronous services in the background, as in you might be doing a lot of asynchronous tasks, a lot of web crawling, you have a lot of users wanting to do a lot of different things with your application, and you have to scale these asynchronous services to multiple servers, you might start needing more robust solutions, but that would be at pretty big scale. So these ones will serve you well for a very, very long time. The docs are great, and I am a huge fan. All right. You've set up a basic asynchronous service. Tasks are running in the background. You're super excited. Now, did you? Nope. Yep. I'm really good at using technology. I don't want to brag or anything.
So now the question is, we've automated our deployments. We're handling asynchronous tasks, but we're running out of money. We have two big problems. We're running out of money, and so we're thinking about having to go to VCs, and they're going to ask about traction. They're going to want pretty graphs like this. But the other problem is we've got hackers that are trying to break into our system. So the question is, how do we handle that? Do we first go to the VCs for money, or do we try to handle our security issues first? Choice is up to you. So this is j.mp/track TRAC-SEC. Security. All right, looks like security has double the votes, so we're going to go with security. Clearly, our web application and our web server have some major security concerns right now. We're logging in as root. We're using a password. We haven't set up any sort of public-private key in order to log in. And these guys are coming after us. So we're going to make some very basic security upgrades to our server itself. We're not even going to address the issues that may be occurring from an application level. We're simply going to do some very basic updates to the web server, to the server itself. First off, no root login. We want SSH key logins only, and we're going to install two packages, fail-to-ban and unintended upgrades. So here's how we would do that. We log into our machine. We SSH back into our machine. This isn't something that we've automated. And we do a group add for deployers. We then add, with the second command, we open up sudoers. We should copy the sudoers file to a backup file, but we would edit the actual sudoers file, and we would change or add one line. So that would be a deployers all equals all. What happens is any user that is in the deployers group would have sudo privileges. So we're not going to log in as root anymore. We're going to log in as a user that is in the deployers group so that we can then use sudo commands. We would add a user called deployer. We would set the password of deployer. And then we'd change the user to be a part of the deployers group. Make a directory, a .ssh directory for the deployer. Change the ownership of that directory because we're currently as root right now. So we have to change the ownership of the deployer home directory and the .ssh directory to be under deployer and deployers for the ownership of the user and the group. We would edit the SSHD configuration and change 2 lines. And let's say we're on Ubuntu right now. Password authentication, we would set it to no. We do not do password authentication, and we do not use a password authentication manager. We create a public-private key using the SSH keygen. We copy our public key to be an authorized key. And then we SCP from our local system onto a remote system the 3 files that we created, or the public key and the authorized key. And then we install fail to ban. So we would do a sudo apt-get fail to ban. We'd install unattended upgrades, and we'd configure unattended upgrades. So what unattended upgrades would do is it would install security updates automatically for any packages that we have installed on our system, and fail to ban would prevent many attempted user logins, unauthorized user logins, and then log them. All right, so we've stymied the script kiddies for now. So the question is, we've got one more choice here. Do we have problems with scaling that we need to figure out? Or did we delete all of our data, and now we have to figure out how to handle that? Choice is up to you. So this is j.mp/scale-data. Scaling. Oh, data's catching up. Neck and neck. Scaling or data?
All right, let's go with data. I'm just going to call it and go with data. All right. So you have missing data. And the background story to this is it's something like what my brother did at his first internship. He worked at Trulio when they were really small. And he gets there, and they give him access to everything. He's an intern. He's like a 19-year-old who's taken 2 programming classes at the time. And he gets in there, and he's doing something in the database, and he goes, delete star from users. And then he accidentally hits enter. Yep, that's why you don't give people read-write permissions to your production database. So my brother deleted the entire users table on his first day of his first programming internship. So the rest of it was spent restoring the users table from the backups of data that they had, which they only could do because they had backups of their data. So when you build a production database system, you never want to have a single point of failure. Your data is really important, and you always want to be able to restore it. You want to be able to deal with a problem if your master database goes down. Now, I didn't have time to fix this, but there is a big movement to not call them master slaves, to call them master mirrors and things like that, which I'm totally on board with. So replace that with mirror or replication database, but the basic idea is the same. You have one master database, and that is where all of the writes in your system go. So whenever any user comes in and they write data, or your asynchronous task service is writing data, it all writes it to the master database. The mirror databases, and you can have as many of these as you want, get written to from the master database. So data comes into the master, and then it gets written to the next mirror, and gets written to the next mirror, and so on. So you have these really robust backups of your data. And in fact, clients can come in and read from the mirror databases. They just can't write to them. And that's I had another coworker do this where he one time logged into production and altered data on a production read-only mirror. Not recommended. It totally breaks replication. But anyways, if the master fails, you can default to any one of the mirror databases, which is a great system, you also have more databases to read from, so you can spread out the load. So this is the master mirror system. The second system is the multi-master system. So in this system, every database is a master. Every database can be written to, and then those writes get replicated across the other databases. Now, most companies go with the master mirror system because it's simpler to implement. The multi-master system has some advantages. You can read and write to any database, but it has some challenges, which is that dealing with collisions, data collisions across different databases can get very complicated, especially as you scale and especially as you have more multi-master databases, right? So you can do either one of these. They both involve setting up a system where you have multiple databases, no single point of failure, and backups of your data, so that if one of your databases goes down, you're like, that's fine, we have another database. Like, the site's not gonna go down, like, we're not gonna die. You're still probably gonna be there all night, terrified of whatever it is that's going on that made your master database go down, but you have a backup. And then the final thing that you should do, that companies also do, is they have constant basically just backups of all of the data. So every time data is written to a database, there's a transaction log. Those can get backed up. Those can get copied to just a third-party storage system, so that when you go to, if you delete a bunch of data, like my brother did, either you can change over the master and say, okay, this database is totally ruined, or you can get the logs, the backup logs, and restore the data from there. So there's a couple of different options. You should do both. You should have multiple databases so there's no single point of failure, and you should also have copies of your databases just being logged to a third-party system. And you generally use a third-party system for those backups because the data gets really large. If you're constantly backing up your database and you're constantly backing up all of your data, it's like a massive scale thing, especially as you get more users and more information. And so there are third-party tools out there that you would use when you hit this point. All right, your data is safe for now. If one of your databases gets killed or something bad happens, you have a failover system. But now,
all right, we've put it off as long as we could, but we have to go to the venture capitalists for additional funding. We need to raise money to continue our application.
Those dachshunds are really expensive.
Dachshunds are really expensive. We have one more choice we need you to make. So you go around, you do the 2-week nonstop tour of 40 different VCs, pitching your Dachshund Delivery service over and over again. The question is, do we accept or reject the money from VCs? So this is the final question for the audience. So we can text accept or reject, or go to j.mp/VC dollars. Accept or reject.
Now just know that your VCs can tell you to, build tools for customers and do one-off things, and generally
we know we lose the control of our application if we accept the funding.
But you also get a lot of money, and you can buy ping pong tables and snacks. A lot of snacks. I love the open source crowd. Everyone's like, reject it. Mm-mm, mm-mm. Yeah, exactly. All right. So funding is rejected. Good choice. Those guys were kind of jerks anyways.
So we've rejected the VC money. We stuck to our guns, and we decided we're just going to scrape by for as long as we can. Turned out to be a really good choice. We were able to improve our cash flow. We were able to improve our service. And eventually, we struck riches. And we still own the company.
Bootstrapping for the win.
Massive funding flows through your coffers. You're a great success. But the question is it all just a bubble? So this is our version of the choose your own adventure story. All of this code, this is a Flask application that is running, which accepts SMS input and has web browser voting. So you can go and do your own version of the choose your own adventure story. It's an open source Flask application on GitHub. And if you are interested in the code and tutorials that show how you can build an application like this and add more functionality and then create your own presentations, go to this link, j.mp/VC PyCon-CYOA. This will give you the code. It will give you a link to a blog post that I wrote that just has the code and other blog posts that you can learn from there. So thank you all very much. My name is Matt Makai. I'm a developer evangelist with Twilio. This is Kate Heddleston, and we really appreciate you participating in our story today. Thank you.
Yeah. So we've got a little bit of time left. If anyone has questions, you're welcome to, I don't know if there's a microphone, or you can just stand up and yell them really loudly.
There's a microphone in the middle.
Yeah, there's a microphone in the middle back. I can see it now. So you're welcome to ask questions. If you want to come and ask us questions later, too, we'll be outside in the hallway. Yeah, that's about it.
I have the first question. So we talked about having an asynchronous queue, and it's actually very hard to debug it, to test it when there's problems. Do you have any recommendations on how to get that part of the application correct?
Testing your asynchronous code. So we didn't talk a ton about testing in here, but I mean, I hope everyone knows that testing is a really good thing. And there's a lot of tools out there now for continuous integration that will run your tests when you merge code into GitHub. But testing asynchronous code, you're right, is very difficult, right? Because you have, if you're testing a function that has an asynchronous call, you're not actually waiting for that call to complete. There's a talk going on right now that you should watch the video of, where someone is giving a talk on testing asynchronous code. And that is where I would point you, basically, which is just tools for testing these types of things. And there's a bunch of things you can do. You can mock code. You can try to test database state, but that's going to be really hard. So sometimes you can just test to make sure that the network calls either call or fail appropriately, things like that. It can get very complicated. So I'm going to point you to that talk, and you should go watch that.
Hey, so I really enjoyed this talk. I really like the format. One of the reasons why I was a bad kid when I was growing up is because when I read a Choose Your Own Adventure book, I would always look at all the other outcomes. So are these slides online so that I can see all the paths we didn't take today?
They are not.
Oh, will you put them online?
I will certainly consider putting them online. I'll make that happen. Okay. And I'll post a link to it with the on the blog post that I put up.
Cool. Thank you.
So I think no more
Cool.
questions? Or?
Yeah.
Okay,
Cool.
well,
Thank you all very
Great.
much for coming out.
Have a good afternoon, everyone.